This is the study guide for algebra, quiz 13. Let's take a look at our first problem here. And it's asking us to graph the system or graph the function. And so what I'm going to end up doing here is starting with looking at the equation and seeing if it's in slope-intercept form or not. And it is. We've got it in slope-intercept form. So this number right here, -1, is our y-intercept, and my slope is 1 to 2. And so I'm going to start up or down one space and then use the slope. And again, I'm going up one space over two spaces each time and getting some points on the line. I could also go the other direction, down 1, 2 to the left. Now I'm going to look at the type of line to draw. It has this line underneath. That tells me it's going to end up being a solid line, and I end up saying since y is greater than or equal to, that tells me to shade above line. So we'll just say shade there as well. So shade above the line. So solid line, and we shade above the line because the values that are true are going to be greater. The y values are bigger above. And we can check. And so the way to check is to pick a point. And so if, let's say I pick this point right here. This is in the shaded region, 0, 0. It's an easy point to deal with. See, I can prove it by going ahead and substituting the point in for y and x. So 0 is greater than or equal to 0 minus 1. That's true. 0 is greater than or equal to -1. So when we get it to be true, that tells us that was the correct region to shade. So on this next one, it's a good one for xy intercepts. So I'm going to do 3x is less than 12. So for the x-intercept, x is less than 4. Over here, -2y is less than 12. So divided by -2 gives me y is greater than -6 because I had to divide by a negative, which switched the inequality sign. So I'll go ahead and plot those points, 4 spaces to the right and 6 spaces down. It's going to put me underneath this graph. And then this time I have a dashed line. So it's not equal to, so we're going to end up using that dashed line to represent that the points on the line are not solutions. So that's what that ends up representing. So from there I need to figure out the shading. It says x is less. Less means I would end up shading to the left of this line. And then over here, this should agree. So let's see if it does. Y is greater. Greater means above. So I end up shading above this line once more. So we can check. Again, we can prove it by picking a point. Hey, we got 0, 0 again to try. So let's try it. 0, 0. This will give us a true solution if it works. Let's see if it does. 0 minus 0 is less than 12. So I plugged in 0 for x, 0 for y. Did the multiplication, I end up with 0. And 0 is less than 12. So when that's true, that tells us that we did shade in the correct location. Here we have to graph a system. So the first thing I'm going to do is add this 2x to the other side. And I'm left with a new equation. It looks a little different. So y is greater than or equal to 2x minus 1. So I'll go ahead and graph that line. Start down here at -1. Use the slope of 2 to 1, means I'm going up 2 spaces over 1 to the right. I could also go the other direction, down 2, 1 to the left. It's a solid line because it has that line underneath the inequality sign. And this one says y greater, so that tells me to shade above this line. So let's take a look at the next one. It's a great one for xy intercepts. So on this one, I'm going to go ahead and set 2x less than 10, and I'm going to do -5y less than 10. So when I do that work, x is less than 5, and y is greater, because I divided by the negative, greater than -2. So we'll plot those points. -2 is down here, x greater or less than 5 over here. Dashed line this time, so it does not equal, so we show that with a dashed line. And I look at the inequality. So x is less. Less means left, so that's the direction I would shade. And also, I could use this one to help me see if I did it right. Y greater means above. So yes, those match. So we know we did it right. So where do they agree? They agree in this region right in here, above both lines, above the black, above the blue. So we'll shade here. So everything in this region is a region in which we'd have true solutions. So let's check. Let's verify. Let's plug in. Hey, we get to try 0, 0 again. It's in that region. So if I plug 0 in for these two x's and y's, so I'll try that 0, 0, I end up with a 0 is greater than or equal to -1. That's true. Plug in 0 here, they cancel out, and it says 0 is less than 10. And so you see how it's true for both. When it's true for both, that means yes, we did end up shading in the correct region. Let's take a look at the next problem. We have another system of inequalities. This one's all set up for us to graph using the intercept or slope-intercept form. So I'm going to go down 4 spaces, 1, 2, 3, 4. That's the y-intercept here. Slope is 1 to 1. So going up to the right each time. Draw a line, another dash line, because it does not have that equal sign underneath. It doesn't have that line underneath the inequality sign. Y is greater means you're going to end up shading above this line. Let's take a look at the next line. It says y is less than or equal to negative 1/2 x plus 1. So negative slope, starting with the y-intercept at 1. Negative slope means you're going down to the right. And I'll get a few more points on that line. This time it's a solid line because it has the line underneath. Get those 4 regions showing so you can see which way to shade. So y less, less means below. So you'd shade below the blue, above the black. Where they agree is right in here. And look, we get 0, 0 again. So aren't we fortunate? So we get to try that point once more just to prove it. So if you didn't have that point, you might try a different one. But this one works, should work with both inequalities. Let's see if it does. So when we go ahead and substitute in, 0 is greater than negative 4. 0 in for the x, 0 in for the y. That's true. And so that works for that one. Let's see if it works for this one. Y, which is 0 now. This is 0. And it's y, or 0 is less than or equal to 1. That's true as well. So we definitely are correct in the region that we shade. So on this next one, it says determine whether the point 618 lies on the line defined by this equation. Well, let's just substitute. Let's take this 6, which is x, and put it in for x in that equation below. 18 is y, and it's going to go in for y. So I'm going to write 2/3 times by 6. And then equals 1/3 times by 18 minus 2. And so from there, put the parenthesis around the 18. I'm going to look for some cross canceling. 3 goes into 6 2 times. Multiplying across gives me 4. On this other side, 3 goes into 18 6 times. Multiplying across gives me 6. But then bring down that minus 2 and then do the subtraction. So we end up with 4 equals 4, which is an identity. So when I get an identity like that, that tells me yes, the point 6, 18 is a solution of, and then we'll write down the equation, 2/3 x equals 1/3 y minus 2. That would be our answer right there. But make sure you show me the proof. Show me how you substituted and you get an identity. If it was not an identity, then you would say, no, it's not. The next one asks us for x, y intercepts. So for the x-intercept, I'm going to end up setting y equal to 0 and cover that term up. And I'm left with 1/16 x equals 3. So I'm going to multiply by the reciprocal to cancel out that fraction. Do the same thing on this side. And you'll see how those 16s cancel, leaving me with x. 3 times 16 gives us 48. So the x-intercept is 48, 0. So the x-intercept is when y is 0, and that's what we get. So for the y-intercept, I'm going to do the same thing, except this time we'll set x equal to 0. So set x equal to 0, cancels out the 1/16 x, leaves me with negative 3y is 3. Dividing by negative 3 gives me my answer. Y is by itself now. Y is negative 1. So the point is 0, negative 1. So that's what they're asking for, the x-intercept and the y-intercept. And you can write your answer in the ordered pair form, or I would even take these answers as well. Either form will work. Let's take a look at the last set of problems here. It says to write an equation in of line in slope-intercept form. Okay, slope-intercept form is this form. Y equals mx plus b. So we want to get y by itself. But they give us a point and a slope. So we're going to use point slope. So point slope goes this way. We have y minus y1 equals m times x minus x1. So we go ahead and substitute in. So I've got y minus 8 equals, and then the slope, negative 1/3 times by x minus negative 3. So I'll go ahead and add the opposite here and distribute. And so I'm left with y minus 8 equals negative 1/3 x, negative 1/3 x minus 1. How did I get that? Well, the 3's cancel out here, leaving me just with 1. 1 times negative 1 makes minus 1. So I'll just add the 8 to both sides. And that'll give me my answer. Y equals negative 1/3 x plus 7. And looking at the next one, it says to write an equation of the line again in slope-intercept form. This time they give me just 2 points. So we first have to find the slope of the line. Here's our formula. Y minus y1 over x minus x1. So I do this subtraction. I'll do 10 minus negative 2. Those are the two y values right here. And then the two x values are 3 and negative 1. So since I started with the 10, I got to start with the 3. So 3 minus 1. So I'll add the opposite again here. And that gives me 12 over 2, which is 6. So once I have that slope, then I get to pick either point. Pick either point and use point slope. And so point slope. And so we'll go ahead and do that. So we use the same formula as we wrote down over here. So I'm going to pick this point right here. This is the point I'm going to use, 1, negative 2. So I'm going to write y minus negative 2 equals the slope of 6 times by x minus 1. So I'll add the opposite here, distribute, and I've got y plus 2 equals 6x minus 6. So when I go ahead and subtract the 2 from all sides, I'm left with y equals 6x minus 8. That is our answer. So let's take a look at the last one here. It says Owen charges a fee of $350 and $15 each hour. Ted charges an initial fee of $2.99, $18 an hour is what he charges. After how many hours until the two companies charge the same? Same means equal. So we want to write an equation for Owen's charge. Owen's charge is, or equals, the $15 each hour. And we're going to say x equals the number of hours. So 15x plus 350, where we have the next person, Ted's charge is, and then his charge is $18 an hour plus $2.99. So what we want to do is we want to find out when they're going to be the same. So we want to set Owen's charge equal to Ted's charge. And so we'll write down their charges. 15x plus 350 equals 18x plus 2.99. And so from there we go ahead and just do opposite operations. So I'm going to subtract the 15x from both sides. I'll subtract the 2.99 from both sides, and I'm left with 51 equals 3x. So I divide by 3, and I've got the answer. 17 hours is how many hours it's going to be until the two companies charge the same. But then they want us to find out what that charge is. So to find out the charge, either one is going to give us the same answer. So it doesn't matter which one you substitute into. I'm going to use 15x plus 350. I'm going to substitute the 17 in for x. So I do that work. 15 times 17 gives me 255. And then I've got to also add on that 350. So now I add those two numbers, and that gives me $605 is the charge after the 17 hours. Well, those are the types of problems you're going to see on the test. Good luck.